hour 15. I am so glad all of you are here, and I am pleased to be joined this morning by Kirby Runyon, Dr. Kirby Runyon. He is one of our science team members, and we're going to be talking about citizen science and the things we're dreaming of exploring and researching with all of you. First, I do want to do a roundup of where we are. This is a fundraiser. I hate fundraising. We have been having confusion with the Patreon interface. I have things sorted, so I'm just going to be updating the number when notifications come in. I apologize. Thank you. Whatever just happened, we have stars on stream. Thank you for subbing Null Denominator. Thank you so much. So we're currently sitting at not a palindrome on Countful. We are at $4,555. To get to a palindrome, I calculated this number earlier. I then accidentally deleted it. It was $109. So if you give $109 or a combination of people working together give $109, Countful will be back to a palindrome. On Patreon, we are currently sitting at $1,491 per month. And that number may round itself on Patreon. So if you don't see changes on the website, there's both caching going on and rounding going on. We see everything that is happening, and we are grateful for all that you're giving. Actually, I don't know where the chat is on your screen. Wherever the chat is on your screen, we are currently on the PayPal charity, sitting at $290. And I know there's a whole lot of ways that you can give. And the thing that we're really hoping for is to see as many people in our audience as possible give that $5 a month that allows us to fill your brain and give you an unlimited cup of science. Yeah, and as Null Denominator is pointing out in the Twitch chat, Patreon does let people pay by the year. So if you give $5 a month, it will let you do that all at once, and it actually discounts things for you for prepaying for the year. And so yeah, this is where we're at. I have to admit that the people who pay monthly, we're super grateful for you, because that means we get money coming in every single month that we can count on as a study stream in the background. And yeah, the economy is really bad right now. I woke up to NPR and they were talking about how people are using their credit cards for Christmas, how no one is spending more than they have to, and times are tough. And I'm grateful for all of you being here to keep us going. And when Kirby comes back, Kirby is one of our scientists. There he is.
I was doing neck stretching exercises to be healthy.
All right. So we are currently continuing to suffer the curse of CosmoQuest. I don't know what's going on this year, but our other team scientist, Stuart Robbins, is unfortunately dealing with having to replace a card this weekend, which is why he's not on this session. We are dealing with, we lost Jason yesterday midway through the day to an allergy attack. Kirby and I are both dealing with neck pain, although I'm at least more used to it, so better prepared to deal, I think, and knowing how to put my body so it hurts less. We appreciate you being here for however long you make it. And when you hit the point of, and now I must go, we fully understand. Now, you and I put in a grant about a year and a half ago to study lunar melt. And that eventually led to the mappers.psi.edu program.
Yeah.
And we really want to bring citizen science home to CosmoQuest, which is privately funded, so that we don't have to worry about DEI issues. We can be our queer and disabled and seeking equity and building a better world group of people as much as we want. Yeah.
You want me to jump in there?
Yeah, I do.
Yeah. Yeah. Well, good morning, everybody. Yeah. So Pamela and I, we have we have this grant from NASA,
Yeah.
and that's allowed us to develop this really great interface for allowing you, citizen scientists, without having to go to grad school and get a PhD, to actually contribute to some of the science we're doing. And one of the things that has interested me, now I'm a planetary geologist. I spend most of my time looking at rocks on other planets. And Pamela, is my screen on the stream?
Yeah.
My shared screen?
Yeah.
Okay, yeah. So we're looking at roughly the near side of the moon right now. This is not our program. This is another web interface that's
Yeah.
still wonderful. It's called QuickMap, and it layers almost all spacecraft imagery of the moon that we've ever had. Now you'll notice that it's just covered with impact craters like everywhere. There's craters and craters and craters and craters and craters. And when an asteroid or a meteoroid hits a planetary surface, it melts a lot of that rock. This doesn't get talked about like I think it should. It's super cool. If you think molten rock is awesome, and I do, it's not just volcanoes that have that, it's also asteroid impacts. And for the youngest craters on the moon, and by youngest, I'm talking about less than about 100 million years old, you can still see the flowy morphology. It's like you took molten peanut butter, maple syrup, get another yummy gooey thing of your liking, and flowed them all together, and then put it in the freezer and looked at the yummy gooey morphologies, the shapes, I should say, that occur. And this, so quick map, I'm going to zoom into a crater here that we haven't talked, that Pamela and I have not really dealt with a whole lot, but it's also a very young crater. It is featured in the voice transcripts from the Apollo 17 crew as they orbited the moon in 1972. This is a crater called Proclus, Proclus. And if I zoom out, you can actually see it's got these white rays that go streaking all over the place, streaking in an appropriate sort of way. And as we move in on as we zoom in on the crater, the bottom floor of this crater, as we zoom in, it gets higher resolution spacecraft images. It's got all these really funky knobs and cracks and like streams where you can literally see where lava was. It's not technically lava, but sometimes it's easy to call it lava. Lava was flowing through here, and it's just these beautiful, beautiful shapes, flowing features all flowing together. And when we map that, and when you map that as part of CosmoQuest on mappers.psi.edu, what you're doing is you're providing information for us to then feed into these numerical computer models. We use a program called COMSOL that combines lots of different areas of physics together: fluid mechanics, traditional mechanics, thermodynamics, and it figures out how goopy, how thick that lava had to be. We look at how many, like, quote unquote ice cubes, frozen blocks of rock, are within that. So here's for example a pond where impact melt was just sitting there, just chilling, just sort of cooled in place, but it was transporting rocks. And if it was strong enough to transport that rock, that allows you to figure out how strong that flow was. But the problem, or really it's not a problem, it's an opportunity. The opportunity is that there are so many of these young craters all over the moon, and we know where the young craters are, and we know roughly how old they are, like less than 100 million years old, so maybe not super well, but they all started off with impact melt deposits in their floor. And if we zoom into some like more degraded crater, you won't see any really recognizable impact melt. Like this one's been beat up pretty bad. I'm not sure which crater this is off the top of my head, but those flow features are, if they're there, they're much more muted, but they're generally absent, and you just have this smooth, generic gray lunar landscape. But there's so many of these craters that we can't possibly map all the flow by ourselves. And so we ask you, citizen scientists, to join in on that, get credit in peer-reviewed papers for doing that, contribute to science that is actually enhancing our understanding of the moon. And when you also support CosmoQuest, you're also supporting me as one of the scientists here at the Planetary Science Institute. And that allows Pamela and I working together to set up these programs to then allow you to go in and map stuff, which then it snowballs, and all of science gets to grow. The sum total of human knowledge gets to be expanded, no matter who you are in the world, no matter where you are. And we can all enjoy the passion, beauty, and joy of space exploration and our cosmic backyard here on the moon.
And And Kirby is someone who, like Allie and I, is working on engaging people in science as much as he can, but we all have side hustles.
Yeah.
Kirby is out there doing educational programs, taking teachers out into the landscape. He is taking people on zero G rides and helping them learn how to do their experiments, do their art, do whatever creative process it is. And science is a creative process
Hmm.
while flying on these parabolic flights. We all are doing so many different things because we want to be scientists when we grow up still.
Still.
And there's no straightforward path to being a full-time scientist anymore. And
Yeah. I
so
was just going to say, most the normal way that a planetary scientist or a planetary astronomer would make their money is by writing grants to NASA or the National
yeah,
Science Foundation, hopefully getting them funded. And that's still happening, but not as reliably or as much anymore.
yeah,
And but what time and again has shown is that a civilization, a society that invests in science, raises the tide for everyone. The science doesn't the lunar geology we're doing doesn't just quote unquote stay on the moon. The type because we're engaging people with science, all of this passion for science is dribbles out into the rest of the economy, into the rest of academia, into the rest of life. And I know doctors who are coming up with incredible treatments and cures who were inspired not actually by medicine, but by
yeah.
space exploration. So they're inspired by the space exploration. They think, oh, science is cool. It's this whole way of thinking and not just understanding the universe, but kind of defining how we understand the universe. And then they go and do something immediately practical, like figuring out how to fix pinched nerves.
which we both suffer from.
Yeah.
C4 is not my friend on
Uh,
either the explosive or the spinal category. I just broke Allie slightly in the background. Um, I love its craters all the way down in this particular section of the image.
mhm.
And and Jessica's here. Jessica was one of our original moon mappers back with our OG moon mappers project back in 2012. And I love that we have expertise developed over decades within this community. That's just an amazing aspect. And what we're seeing as Kirby scrolls around the moon is the variety of terrains that exist there. So here we're looking at a boulder field with ponded former melt.
Mhm.
And machine learning algorithms can't just look at one area and another area and generalize what they're seeing the way a human brain can.
Right.
And so we require your human minds to do this kind of research. We can't just ask the AI. And there may come a day that the work that all of you do allow us to train a machine vision algorithm to see these things. But we're so far from doing that. We need to get there because the moon is big and human beings there just aren't enough of it, us, to get all the way through it.
Right.
We want to be able to do this at the highest of resolutions because we're literally looking for the places that are safe to land and scientifically interesting to explore. This is not an aspirational statement. This is a true statement. And working with Kirby, I'm seeing things that I didn't see when I started writing these kinds of grants 10, 15 years ago, because he's like, this is what we need for the Artemis program to succeed. And can you tie in what we're doing to that Artemis future?
Sure.
And part of our fundraising is being able to cover Artemis 2 live and bring you that return of humans going around the moon that is in the coming months.
I can't wait for that. But sure, I mean, right now NASA's targeting the south pole of the moon for an astronaut return, and there's reasons for that, and some of them are good, but um, there are other places on the moon that are really, if not more interesting. I've just zoomed into one of my probably all-time favorite spots on the moon. This is the Aristarchus Plateau, featuring the crater Aristarchus, featuring something nicknamed the Cobra Head. This was a volcano that was spewing fire fountains out that then flowed up to the north, northwest, and then arced down to the southwest. But for astronauts in a lander, in a human lander, either the Starship or the Blue Origin, is it Blue Moon, or
Yeah.
something like that?
Yeah, it's the
Um,
Blue Moon Mark 1 lander.
Okay, you want to land somewhere, as Matt Gollenbeck from JPL would say, smooth, flat, and boring, because
Yeah.
that's what's safe for landing. The problem with smooth, flat, and boring is it's usually not interesting for science. However, if you can get a smooth, flat, and boring spot next to a cool science spot, then hopefully it's not too far of a walk or a drive to get there. So, conceivably, astronauts could land right around here where it's flat. Um, One thing that we would really, really want to sample around Aristarchus crater is the impact melt.
Yeah.
Not all of the impact melt is on the floor either. A lot of this impact melt has been splashed onto the surface, and sometimes you can see if you really zoom in. So, like, here might be like a pond of impact melt. Whenever you melt a rock and then you cool it, you allow it to recrystallize, what you've just done is something called resetting its age. The way we tell how old rocks are is by looking at the ratio of isotopes, the elements with different numbers of neutrons in them. And radioactive elements decay into something called a daughter isotope. And by doing some fancy math and looking at the ratio between how much of the daughter isotope is there and how much of the starting isotope is there, combined with how long we know what the half life is, how long it takes to decay, you can calculate how long ago it must have been when it was molten, when it was melted. And so with craters, this impact melt cooled within a few minutes, hours, and days of when the crater formed. So that means that the age of the impact melt is also the age of the crater. And if we know the age of the crater, we can start piecing together the history of the moon. Um, One of the things I'm fond of telling anyone who will listen, my students, but anyone who will listen really, is that geology is a forensic science. What we're doing on the moon here, this is geology. It's not Earth geology, it's lunar geology. Geology is forensics. Something happened in the past, and just like how an investigator looks for clues in an abandoned alley or by a broken window by a house or whatever, you can reconstruct what had to have happened in the past to lead to the present. And so by piecing together all of these separate clues of the size of the crater, the location of the melt, the age of the melt, the composition of the melt, is it rich in olivine, or is it poor in the mineral olivine, for instance? You can tell a whole lot about where that rock came from that was melted. If an asteroid penetrates very deeply into the moon, sometimes you might expose the mantle. All planets, and I include the moon as a planet, inclusive person that I am. The almost the entire mantle of the moon, if you could see it, is green. It's this beautiful mineral olivine, gem variety peridot, I believe, the August
Yeah.
birthstone. And that green part of the mantle is also present on Earth and Mars. It's just really hard to get at because we literally can't drill that deep or dig that deep. And so by excavating these deep layers of melt, by melting it, sometimes it brings up rock from deep underground, and we can sort of use craters as a way to X-ray or get an MRI of the inside of the moon, of the inside of other planets, and better understand what they are and how they got that way.
And one of the things I've really loved in the past year and a half or so that we've been trying to figure out how to do a lot of these things is you're always looking for new ways to understand craters, including by going to places here on our world
Hmm.
that are lunar analogs that allow us to start to understand the physics in new ways. We put in a grant that unfortunately just felt they were like, this is not planety enough. Where we were trying to look at Schooner Crater here on Earth, which was formed through an atomic blast and would allow us to really get at this is what happens when these kinds of energies interact with rock without having to like slam an asteroid into the planet,
Right.
which could be catastrophic for other reasons. And with projects like that, it allows us to start to also imagine, so let's create VR experiences where you can't send human beings into Schooner Crater because it's a little bit radioactive, but you can send in drones and other equipment that can capture images that with modern VR headsets, you can start to imagine doing field work in a virtual environment using data obtained by your friendly robot companion. And this is the future that we're heading in, where things that we do on our world allow us to understand other worlds as we
Hmm.
step out beyond our current planetary limitation here on Earth. And
Yeah.
is that a volcanic cone?
Yeah, you nailed it. Yes, it is. So there are not very many of these on the
Yeah.
moon, but they're there. This is called a volcanic cinder cone, and Earth has tons of these things. I mean, uh, a lot of them. So everywhere from New Mexico to Arizona to Southern California, there's a lot of extinct volcanism in the American Southwest.
Yeah.
And I flew over some of them yesterday. I just flew back back east from a conference in Phoenix yesterday. And looking out the window, I saw these volcanic cinder cones. These are also, if you go up on the slopes of Mauna Loa in Hawaii, you can also see some of these things sticking up on top of the bigger volcanic slope. And so these are usually like one shot and done. Like this probably only ever erupted once or a series of short eruptions altogether, and then it stopped. For some reason, the magmatic plumbing, the way the magma underground took advantage of cracks to get up to the surface, that plumbing for whatever reason probably shut down after this eruption. And one thing that I'm struck by is how clean this
Yeah.
boundary is between the ground over here and the edge of the cinder cone. What looks like what happened is that this cinder cone started to drown itself in the lava that it was erupting. So all this lava is coming out here. It's flowing and creating this huge, vast lava plain. I mean, what all these smooth dark areas here, all the smooth dark areas, this is all cooled lava from hundreds of volcanic vents, and one of the volcanic vents is right here. And so it looks like, yeah, in fact, this is definitely older than this. Just because of this really clean, we would call this an embayment relationship because the liquidy lava flows into bays. It embays the higher topography, and you get this really nice, clean, what we would call geologic contact right here.
I would like
Um,
to maintain that where astronomers are truly terrible at naming things, geologists just make up words. And embayment is a fabulous word, but it is the kind of thing that every time I see it, I have to go, oh no, what does that mean? And we just give things meaningless names, and somehow that's easier to remember.
Embayment's easier to remember, or meaningless
No, no,
names are
no.
easier to
Like
remember?
dark matter is words I know combined in a way that mean nothing, but
Ah,
yeah.
yeah. Okay, gotcha. Um, so again, if you join us to do some of the citizen scientist mapping and you choose to donate to CosmoQuest, please, you
Yeah.
will help fund continued detailed geologic mapping, for which there's just too much for us professionals, us PhD nerds, to do by ourselves.
And
Here's a
can
really
you
cool
stay
volcanic
on
vent,
this field? Zoom back out just a snort,
a snert.
a snort, and
Speaking of inventing words,
that was a grandma word. So what you can see on this image right now is the mosaic images don't all have the same background
Mhm.
levels. And we have a second project. As I said, the other scientist, Stuart Robbins, couldn't be on with us. He had a really bad car wreck. He's fine. Car was totaled. So he is unfortunately having to deal with that this weekend. And the Mars Mosaic project is he's created software to combine images, in this case from Mars Reconnaissance Orbiter. We're looking at images from Lunar Reconnaissance Orbiter. And the software gets rid of this problem entirely with how the backgrounds don't match. And this allows you to start looking at features much more efficiently than when your brain is trying to figure out, okay, this strand that I'm seeing going between these images, that's the same strand, and trying to spot color variations in the regolith and the soils is really hard when the backgrounds don't match. And the reason we need your help is part of making all of these mosaics with the mapping having matching backgrounds is you have to make sure you have picture perfect, pixel perfect alignments as well as brightness scaling, or you're shifting features. And if you think a feature is in one place and it got shifted 6 pixels to the right in the process, that changes the well, map, literally changes the map. And we're getting your help to make sure we don't shift things around in the process. And I'm hoping that over time we can see this kind of algorithm get used to understand more and more worlds as we extend what we're able to do. The boundaries between data sets can be a pain in the butt, and this one's particularly annoying because the sun has shifted from the left to the right or the right to the left. I don't know which image is before and after, and that change makes it just look like the landscape suddenly tilted radically, and it didn't. It's the sun is in a different place in the sky for those two different images.
Yeah. And you can see here where like the alignment of these images is good, but it's not perfect. Um, and depending on what you're doing, it might be good enough. But if you want a perfect photomosaic of the moon, it's not quite good enough. And yeah, so I'm excited to see Stuart Robbins progress, and have all of you get to participate in that to your heart's content. What's cool about this image geologically is we've got two volcanic centers right here in what looks like some terrain that, I'm not sure. I was going to say well, it's definitely had some tectonic modification. Tectonic is just the fancy word for stress in a planet's crust, either pushing or squeezing or sliding. And this wrinkly ridge right here, which is literally called a wrinkle ridge, shows some of the areas where, as this lava has cooled and contracted, part of the lava has it's buckled and it's rafted on top of the other one. So that if you do that all along a certain area, you get this uplifted hill that's really wiggly. And it's a called in structural geology we would call that a thrust fault. And when it looks like this on the moon or on Mars, we call it a wrinkle ridge. I mean, on other planets too. But here's where forensics comes in. And if you join us in CosmoQuest, you can learn more of the forensics that is geology. And it looks like we had a lava eruption happen, carve this channel, and it was only after this channel carved that this wrinkle ridge formed from the compression of this area. How do we know that, or how do we suspect that? It's because part of the channel has also been wrinkled and pushed up right there. This is called the law of superposition in geology. If the wrinkle ridge happened first and then you had lava flowing here, you wouldn't expect to see the wrinkle ridge cross the lava channel right there.
It's really amazing. And what's cool to me is so you're out here, you're figuring out the geology of the moon. You've worked on other worlds over the time. I
Hmm.
know you and Stuart were both part of New Horizons at one
That's right.
point. CosmoQuest worked with New Horizons as well. We just were looking for the follow on object, not Pluto. Um, you also recently went to, I believe, Goddard and fired things at things.
Yeah, that wasn't Goddard. That was NASA Ames
Oh,
in
wrong
the
base.
Silicon
Yes,
Valley area.
sorry.
Yeah, so we were making experimental craters, and with a hypervelocity gun, um, to simulate impact cratering. So NASA Ames Research Center has this very cool facility called the NASA Ames Vertical Gun Range, and you can fire projectiles from anywhere from 1 to 6 kilometers per second. That's almost orbital velocity. And we were doing it into buckets of sand and ice mixtures to simulate cratering at the lunar South Pole. And by doing that, we were able to infer the how the cratering happens, how the cratering happens, and what the resulting crater morphology looks like. And that was a way where, we've seen craters form, but we almost never get to see them in the process of forming. We see the result of cratering, but we don't see them forming. So that means we have to go to the lab and do that. And that generates lots and lots of data, some of which is involving tracking individual particles frame by frame by frame. And it's very tedious and it's a lot of work, but every one of them needs to get done. And we're hoping to have another way for you guys to get involved at some point in the future where you can help us figure out how fast the stuff leaving the crater is. It's called ejecta because it's getting ejected from the crater.
So I know you're going to have to go soon. We do have a question from Anakim Luke.
Yeah,
They are asking if you could go anywhere on the moon just to have fun, where would you go?
I love that question. Just to have fun, I would probably still do Aristarchus Plateau because I'm a sucker for amazing natural vistas and scenery. And standing on the rim of this canyon would be marvelous, as would be standing on the rim of this crater or standing on the peak of this mountain in the middle of the crater. Just taking in that view. And then, of course, I would go play in the light 1/6 gravity of the Earth, which you can do anywhere on the moon, where the acceleration of gravity, unlike Earth, which is 9.8 meters per second squared, the moon is 1.6 meters per second squared. So I just have fun jumping and running around and throwing stuff in that low gravity. But Aristarchus Plateau would be beautiful. Um, Other beautiful places. I want to show another beautiful place. Let's see. Be not quite South Pole, but it would be in this crater called Schrodinger. and probably standing on one of the mountain rings here that make up this inner ring
I
of the
love how
basin.
cracked this is. This is just wild.
Yeah. And here's another volcanic eruption where you can see this dark splotch around it there. That's from a type of volcanic eruption called a pyroclastic explosion. Pyro, fire, clastic, rock, fire rocks.
Awesome. And these are all things I look forward to building with you. And
Same.
if anyone wants to travel to amazing vistas of volcanism here on Earth, Kirby and I are working with Galactic Medallion Travel out of Florida
That's
to
right.
plan a trip to a volcanic region out in California. We need to have a meeting to work out dates, but this is something
Yep.
that will probably be happening later in 2026.
That's right. Lassen Volcanic Field, a miniature version of Yellowstone National Park. Less touristy, but almost as good.
Yeah, the geology is amazing. The black bears are fewer in number. So thank you, Kirby.
My
I
pleasure.
know that you need to escape. Um, and I'm trying to find a good transition screen. That screen. Okay. So I will talk to folks about the stuff that we're planning and um, pull up some of our information on past citizen science projects to talk to everyone. And we will be back with you when you're in less pain. Please take
Thank you.
care of your neck, my friend.
Thank you. Bye-bye, everyone. Thank
Bye
you.
bye. All right, everyone. I am going to pull up some results of some of the amazing things that we've been able to accomplish together. It's just going to take me a second to rearrange my screen a little bit. Um, we are really having a CosmoQuest curse at the moment between family members not being well, car incidents, personal injuries. Um, I know that this is the story of 2025. It's just one of these things where it's currently a little bit, oh, okay.
We all like to get it out of the way at the same time.
Yeah. I don't know if you heard that, but it was the we all like to get it out of the way at the same time. I could handle with a little bit getting it out of the way at the same time. Is this the slide deck I want? No, that is not the slide deck I want. So if you have any questions, please go ahead and ask. While I'm looking for this, one of the things I just want to talk about briefly is this is a fundraiser during the worst economic situation of my career. 2025 is not a great time to be in science. But we do what we can. We make do with what we can. And I just want to say that we're really grateful for all of you that are here, for all of you that help us keep things going. And I hate fundraising more than anything else. I really want to get to the point where we don't have to constantly ask for funding when we're trying to talk to you about science results. I don't know if we'll ever get there, but it's a goal. And I appreciate you being here because I know I really don't like listening to NPR fund drives. I love NPR. I listen to NPR every day. I do contribute. I'm not someone that needs to be called up by Ira Glass and mocked for my lack of donations. And that's the thing, is it's something that I consume every day. And you being here every day keeps us doing this. It charges us up. It gets us excited. And if you're not in a position to donate, oh my God, I do understand so well. And there's other ways that you can really support us. And one of those ways is to just go write reviews for Escape Velocity Space News, for 365 Days of Astronomy, for all of our different programs, and say, hey, go check this out. This is why I like it. This is why I love it. And things like that don't cost you money to do. It is free to leave a review for a podcast on Spotify. But we live in a world that is currently very weirdly dominated by the algorithm. And we make a whole lot of jokes about the algorithm. But I mean, the truth is, we are really at the whim of the software allowing us to see things or not allowing us to see things. And when the algorithm doesn't like us, and sorry, I'm trying to figure out where a window randomly got opened on my screen that I kind of want. I've had a window hidden from me. When you help us convince the algorithm we are worthy with your likes, with your comments, with your subscriptions on YouTube, which are free, with your follows here on Twitch, which are free, when you click all those different buttons saying, this is cool, this is worthwhile, that helps the algorithm know, okay, I got you. This is something I need to share out with more people. And that helps. It's a small thing, but it matters. So yeah, that's what I've got. And a missing window. I have that and a missing window. There are 3 screens here, and I didn't hear Allie holler, so I'm assuming that the window did not pop up in front of her. Let me try this one more time. I can't figure it, so I'm putting it into presenter view. Oh, there it is. It gave me the window in front of the window I was sharing. Okay, I found it. Okay, so let me change what you are seeing so I can share a slide deck with y'all. I want many things. Not all of them are on the screen in front of me. Let's hide that. Let's embiggen that. All right. So I'm going to give you some context for the kind of stuff we're doing right now. And there's a few of you in our audience who may actually remember this. I don't. 63 years ago, NASA launched its first planetary exploration mission. Up until that point, everything we knew about other worlds, we knew from reflected sunlight that we were able to see here on Earth in our telescopes. But with Mariner 2, we were finally able to go there to make measurements, in this case temperature measurements, that we couldn't make any other way. And when Mariner 2 went past Venus and sent back data that Venus was 900 degrees Fahrenheit, this world that we had imagined as a tropical paradise, we realized it's not a tropical paradise. A lot of science fiction writers were very sad because the world that they used in their stories was not the world they used in their stories. It was a weird time, and it opened the door for today's era of literally going out and exploring planets. And what was really amazing to me is Mariner 2 had 600 bytes of data. There are blue sky posts that contain far more than 600 bytes of data. And over 50 years since then, our technology has changed a lot. Today, the Solar Dynamic Orbiter, and this video that you're seeing is Solar Dynamic Orbiter data. Solar Dynamic Orbiter is recording 320 gigabits of data every single day. This image is from just a couple days ago. It's from December 1st. And our sun right now is doing crazy and wild things that we haven't seen in our lifetimes. What do you need?
Sorry, how many Patreon members are we sitting at?
Okay, let me reload.
Just tell them I'm bugging you.
Okay, I'm being asked questions that require me going to a different screen, and that's okay. I can go to other screens. I have
Sorry,
that capacity.
Her producer is interrupting her.
Yeah. Somewhere there's a button that says analytics. So we're currently on the struggle bus, weirdly, with the Patreon interface. I'm not entirely sure why we're on the struggle bus with the Patreon interface.
You're overcomplicating it.
Okay. Okay, so we are currently sitting at 200 paying patrons.
Yeah, we made our 200.
We made our 200 goal, and when you finish one goal, you increase to the next goal. Our next goal is to get to 300 paying patrons at the $1 a month level or higher. We'd love it if everyone could join us at the $5 a month level and let us give you a bottomless cup of science. Only join us if you're able. All right, so Solar Dynamic Orbit. This is Dr. Ryan French. He's a helioscientist who has been sharing just all of the sun's wild and crazy activities lately. And this is why we're getting so much aurora, is there's coronal mass ejections and flares that are flinging particles our direction. And in the 320 gigabytes that we get from Solar Dynamic Orbiter, that's just one mission. I mean, there's mission after mission out there flooding us all the time with data from space that is literally raining down on our heads to be collected by radio facilities, giant satellite dishes that sometimes can also be used as radio telescopes. And so we have this data flood problem, and it's only about to get worse. Rubin Observatory alone is slated to produce 20 terabytes of data a day. And like, I don't have a computer with a 20 terabyte hard drive. You can't just like hand that to one observer and say, okay, we're going to have more data tomorrow night, process this today, which is what I used to do in grad school. Take the data at night, process it enough the next day to make sure you knew what observations needed to be followed up on. It's overwhelming. And with all the stuff that's coming down, all the stuff that's being gathered on our planet, with moment-to-moment flowing data, our knowledge is growing. We're learning more and more about our universe, but we also find our archives of underutilized data are growing even faster. And this is where we have a problem, a painful irony, actually. We live and work in a time when it should be possible to make amazing discoveries and to come to statistically significant conclusions every day as we explore our universe with previously impossible levels of sensitivity across every wavelength of the electromagnetic spectrum. We should be able to. But the reality is we can only take advantage of some of the data. And this is where we need your help. And there aren't more jobs for astronomers. We can't hire more people to take on the problem like a big business might do. In fact, the number of us who are able to eke out a living as a scientist is going down every day. The amount of money that's available for our salaries is going down. And so those of us who remain, those of us who are fighting to survive in this career, we are finding ways to ask you to climb the ladder of understanding with us by helping us out. We're trying to build an understanding of the universe on a strong foundation of student engagement. We've always tried that, but it doesn't work because, again, there's not enough students. There's so much data. But there are so many of you. And this idea of an ivory tower of academics cordoned off doing their thing in their white lab coats over there. And I'll tell you, professionally, the only time I've worn a white lab coat was when I was in the machine shop, and I was dressed rather goth because that's what I tend to do if left alone, is wear all black. And one of the folks that I worked with saw what I was about to do to the outfit I was wearing and approached me with a white lab coat and was, here, protect your clothing. So that is the only time professionally I've worn a white lab coat. And so here we are in our academic tower, and we need to knock that tower down and invite all of you to come in and join us. And it takes every possible skill set to do and communicate science. And this is what we're working on building up with you can totally do a Dr. Horrible cosplay. It just In fact, I've always wanted to do a Dr. Horrible cosplay, to be honest. It's just not an accurate interpretation of our work experience, although many of the lyrics do punch rather close to home. But yeah, here in our CosmoQuest community, we have people with every possible skill set, and honestly, every possible skill set has a place, has a need. I've reached out to Hexacosacoron asking for art to help communicate ideas. I have reached out to DPI and Ambius and Keeper asking for help with technology. Jessica's been there as someone who's helped us map worlds over time. Guido has been there supporting us in so many different ways, including talking about how Legos are an educational tool. It all builds up, it all helps. And this is where together we are CosmoQuest. Together we have the ability to explore our solar system. And since our launch in 2012, we have explored world after world. When we launched, it was with the Ice Hunters project, looking for Kuiper Belt objects out beyond Pluto, along that path that the New Horizons mission would follow. Now, it turned out the telescope data we had, it contained some Kuiper Belt objects. There are about 500 some odd of you that are on those discovery bulletins, given credit by name for what you discovered. But we didn't find where New Horizon would go, but we provided the justification for them to get time on the Hubble Space Telescope to find MU-69, which is where they did eventually go. We have explored Mercury with MESSENGER data, Mars with Mars Reconnaissance Orbiter data. We continue working on that. Lunar Reconnaissance Orbiter is a workhorse of our community and where we're hoping to bring back more projects. We were there when Dawn got to Vesta. We were there when OSIRIS-REx got to Bennu. And your capability is amazing. There are other projects out there doing citizen science, but this is the community that has the publishable results demonstrating that when you take a group of professionals and you take a group of people from this community and compare their results, statistically, they're basically the same. I mean, there's some differences. It turns out that y'all have a whole lot more patience for marking all the small craters than the professionals do. The professionals hit a point of, I am done with the small stuff. I am not annotating the small stuff. Whereas the professionals are more willing to mark the larger things that have a lot of you wondering, is this a valley or a crater? So there's differences there, but at the end of the day, we can't afford to pay a group of professional astronomers to sit and map out another world and aggregate their data and find the statistical average, which gives us the best results. But I can sit on the internet and say, let's work together. Let's get this done as a community using our unpaid time to explore the solar system. That's what we do. I just wish we could do all of it for free, but we have to get paid occasionally. And this is where we struggle here at CosmoQuest is at the end of the day, we can't do everything for free. We have servers that we have to pay. I have bills that I'm required to pay. Food costs money. This ridiculous true story related to Hangoutathon. Anyone who's here for Hangoutathon, I'm like, what do you want to eat? And I'm very good at buying junk food. We have over on the workbench Triscuits, animal crackers. We have carbs. We have a carb problem, probably. We have Diet Coke. We have Diet Red Bull. Yeah, there's Diet Red Bull in one of the drawers in the refrigerator. Allie's now very excited, I'll have you know.
Because what you all needed was a more caffeinated.
So Allie is standing up to go seek Diet Red Bull. And this year, when I went to buy Allie's go-to snack, which is meat sticks. When we started doing stuff like that, it was like 50 cents a meat stick. 3 of the companies I've bought meat sticks from in the past that I went to buy them from again were like, no, we're not going there. We're not selling meat sticks anymore. And the one that was still selling them, it was going to be $80 for me to get 36 meat sticks. And that was a no-go, I will have you know. There will be no meat sticks harmed in the process of streaming this event. So, yeah, we know costs are tough, but we're trying to figure it out. Guido says, food is expensive, but worth the expense. Still making tomato sauce for spaghetti without meat tonight, though. Yeah. We had, Friday night was lentil, spinach, and sweet potato. Last night was rice and chicken. Chicken was on sale. I found chicken for $2.99 a pound, which was a really good price. We're eating as a group. Annie and Kitten are here cooking, and we're making literally every dollar go as far as it can. Potatoes and rice, I don't get enough protein, but I can at least be full. Yeah, and this is where protein shakes. It's ridiculous, but this is where we're at. So our goal is, if you can, $5 a month. There are 417 people in our Patreon community who don't pay. There's another several thousand people getting our newsletter who don't contribute, and that's okay. There are 200 paying patrons. We'll make it work. It's just really damn hard. All right. I have done my bit, and I am now going to go set up for the next session. During the next session, we are going to be talking about the importance of experiential learning. I'm going to be joined by Liam Kennedy, who you met last night, and Dr. Mark Wagner, who is a colleague of Kirby and mine, and will also be involved in the trip to Lassen National Park if we make that happen. While I set up for that, I'm going to leave you with our rockets of thanks. We are going to stream the names of people who joined Patreon prior to December 1st, and I will be adding the rest of the names next week. So stay tuned. I will be right back, and we will be discussing experiential learning. Thank you.